Using the distance form of a line, determine the distance of a point having the coordinates 1, 2 from the line 4x plus 7y plus 5 equals to 0 measured along the line 2x minus y equals to 0. Okay, so let's try to understand the problem graphically. For this, we are going to consider the xy coordinate plane. So let us consider the line with the equation 4x plus 7y plus 5 equals to 0. Then we're going to consider the point 1, 2. Clearly, that's as a point which is going to lie on the first quadrant. So here we have the point 1, 2. Let's name this as the point A. Now what we'll do, we're going to consider another line with the equation 2x minus y equals to 0. And clearly, this is a line which is going to pass through the origin and also through the point 1, 2. So here we have the line 2x minus y equals to 0 passes through the origin and also through the point 1, 2. Let us suppose that this line intersects the line 4x plus 7y plus 5 equals to 0 at the point B. We're assuming that its coordinates are x, y. The goal will be to determine the length AB. This is the distance of the point A from the line 4x plus 7y plus 5 equals to 0. So we need to find out AB. Okay, fine. Now what we'll do first is we're going to consider the line 2x minus y equals to 0. So we have 2x minus y equals to 0. What we can do is we can rewrite it as y equals to 2x plus 0, or in other words, what we are doing here, we're going to compare it with the slope-intercept form of a line, which is given by y equals to m times x plus c. So here m, that is the slope. Slope is simply defined as the angle that the line makes with the positive direction of x-axis. So this is going to be the angle alpha. So here, if we take tangent of that angle alpha, that is going to be the slope of the line. So here, in our case here we have seen that the m value that's equals to 2, which means that tangent of angle alpha that's equals to 2. So this is going to be the slope of the line 2x minus y equals to 0. Now, why are we even considering to find the slope of this line? Because what we will do here, since this line one passes through 2 points, one is the point A and the other is the point B. So what we can do, we can convert it to the distance form of a line, because the distance form of a line clearly states that we need x minus x1 divided by cosine of angle alpha equals to y minus y1 divided by sine of angle alpha equals to r, where r is simply equals to AP or AB, the distance between the 2 points. So this is the distance form of a line, the distance form of a line. So what we'll do, we're going to convert our equation 2x minus y equals to 0 into the distance form. So let's apply the distance form. However, one needs to be extremely careful while applying the distance form of a line. So here we have used x minus x1 in the numerator and we have used y minus y1. So here the assumption is that if we have the points x comma y and the other point as x1 comma y1, it must be true that the coordinate values of this particular point, let's call it A and this is the point B, the coordinate values of A, the x coordinate as well as the y coordinate, must be greater than the x and y coordinate of B. So in our case, so here as we can see here, the coordinates x and the y coordinate values of A, that's greater than the x and the y coordinates of B, because A lies to the right of B. So here when we apply the distance form, so we will have 1 minus x divided by cosine of angle alpha. This is going to be equals to 2 minus y divided by sine of angle alpha, and that's going to be equals to r, which means that we now have 1 minus x over cosine of angle alpha. This is going to be equals to r, and also 2 minus y divided by sine alpha, that is going to be equals to r as well. Let's isolate x. X, that's going to be equals to 1 minus r cosine alpha, and y is going to be equals to 2 minus r sine alpha. So what we have done here is we have represent the coordinates of the point B in the parametric form. So here r is the parameter. So we have 1 minus r cosine alpha representing the x coordinate and 2 minus r sine alpha representing the y coordinate of point B. We can say now the coordinates of B, which we initially represent as x comma y. This is also equivalent to saying in the parametric form is 1 minus r cosine alpha and 2 minus r sine alpha. Now, the next task will be to determine the value of cosine alpha and sine alpha. But what we have here is only the value of tangent alpha. So, taking the help of tangent alpha, which is equals to 2, we're going to figure out the value of cosine alpha and sine alpha. Now, that's a very simple task here. So it's given here. So let us consider the right angle triangle. Let's name it as the triangle ABC, which is right angle at B. So here we have tangent. Let's say angle C corresponds to angle alpha. So if we take tangent of alpha, this is simply the ratio of the opposite, which is AB, divided by the adjacent, which is BC. And in our case, we are given, we found out that the tangent of alpha, that's equals to 2, or simply put, we can rewrite it as 2 over 1, which means that AB corresponds to 2 and BC corresponds to 1. Now, if we apply the Pythagoras theorem, then the hypotenuse length becomes square root of 5. So what we can do here, we can now easily find out the value of sine alpha. So sine alpha, that is going to be the opposite to that of the hypotenuse. So we have 2 over square root of 5. And cosine of alpha, that's the ratio of the adjacent to the hypotenuse. So we have 1 over square root of 5. Hence, the coordinates of B is going to be, we have 1 minus r times cosine of alpha, or we get 1 minus r over square root of 5. And the y coordinate value, which is 2 minus r sine alpha, so we get 2 minus 2 times r over square root of 5. So here we have successfully represented the coordinates of point B in the parametric form, where r is the parameter here. Okay, now why did we convert the coordinates of B in its parametric form? Because we can use the fact that since B lies on the line 4x plus 7y plus 5 equals to 0, it means that it must satisfy the equation of the line. We are going to have, we have 4 times x. So in place of x, we can replace it with 1 minus r over square root of 5. Added to 7 times y, the y will be 2 minus 2r over square root of 5. Added to 5 equals to 0. Okay, so if once we solve this equation, we will find out the value of r. So let's begin by distributing 4. We get 4 minus 4r over square root of 5. Added to, let's now distribute 7 to get 14 minus 14r over square root of 5 added to 5. That's going to be equals to 0. Okay, further simplification steps. So 14 plus 4, that's 18. 18 plus 5, that's going to be 23. Minus, so we have negative 4r over square root of 5 and negative 14r over square root of 5. That's 18r over square root of 5. That's going to be equals to 0. So let's finally find out the value of r. So r comes out to be 23 times square root of 5 all divided by 18. That is going to be the length r. So thus we can say AB, which is nothing but r, is going to have a length of 23 times square root of 5 over 8 units.